Hey everyone, welcome back. If you've been paying attention to space news over the past few months, you've probably noticed something strange happening. NASA has been acting differently, more urgent, more deliberate, almost like they know something we don't. And maybe they do. Because buried in recent congressional testimony, scattered across technical papers, and hidden in mission timelines, there's a pattern emerging. A pattern that suggests we might be on the verge of the most significant discovery in human history. Multiple NASA scientists, speaking at different conferences, have started using very specific language when discussing upcoming missions. They're not saying, if we find life. They're saying, when? That's a massive shift. The European Space Agency just fast-tracked funding for a biosignature detection mission originally scheduled for 2035. It's now launching in 2027. That's an 8-year acceleration. You don't do that unless you have a very good reason. China announced they're sending a dedicated astrobiology lander to Mars in 2028, 2 years ahead of their original schedule. And NASA? They just requested emergency supplemental funding for what they're calling time-sensitive astrobiology research related to upcoming missions. Something is happening. Behind closed doors, in classified briefings, in datasets the public hasn't seen yet. And if the timeline holds, if the patterns are real, we might have definitive proof of extraterrestrial life by 2026. Maybe earlier. So in this video, I'm going to walk you through exactly what's happening. The missions, the technology, the targets, and the evidence that's building toward what could be the end of our search. Because after thousands of years of wondering if we're alone, we might finally be about to get an answer. Let's dive in. But before we get into the details, I want to talk about something that's been absolutely critical to my ability to research and produce content like this. Today, we have a problem. We're living in an era of information overload. Between work demands, constant notifications, and the mental exhaustion of just existing in 2025, staying focused has become nearly impossible. Most people reach for quick fixes, extra coffee, energy drinks, things that provide a temporary spike followed by an inevitable crash, but there's a better approach. Magic Mind is sponsoring today's video, and I've been using their mental performance shots for the past 3 months. Magic Mind combines organic matcha with nootropics and adaptogens designed specifically for sustained cognitive performance. The key ingredient is L-theanine, which works synergistically with caffeine to provide smooth, jitter-free energy that lasts for hours without the crash. I'm a researcher and writer. My work requires sustained focus for 6 to 8 hours at a stretch. After incorporating Magic Mind into my daily routine, my productive hours increased by nearly 30%. That's not marginal. That's transformative. The afternoon brain fog that used to derail my work? Gone. If you want to try Magic Mind yourself, use the link in the description and code ALIENS2026 to get 48% off your subscription. That's basically half price. Magic Mind also donates to mental health charities with every purchase, and they offer a 100-day money-back guarantee, even if you've used the product. Zero risk. All right, now let's talk about why 2026 might be the year everything changes. To understand what's happening now, we need to go back to 2020. In September of that year, a team of scientists announced they had detected phosphine gas in the atmosphere of Venus. Phosphine is a biosignature candidate because on Earth it's almost exclusively produced by anaerobic bacteria. The media went wild. "Life on Venus!" the headlines screamed. But within weeks, other scientists started poking holes in the detection. The signal was weak. The analysis was questionable. Alternative explanations emerged. By early 2021, The phosphane detection was largely debunked. Most scientists concluded it was either a false positive or the result of some unknown chemical process. But here's what most people don't know. That controversy didn't kill interest in Venus. It supercharged it. Because even though the phosphine claim fell apart, the debate revealed something important. We have no idea what's actually happening in Venus's atmosphere. Our data is decades old. Our models are primitive. If we're ever going to understand whether Venus could harbor life, we need to go back, with better instruments, better technology. And that's exactly what's about to happen. NASA has 2 Venus missions scheduled for the late 2020s. Da Vinci, which will drop a probe through the atmosphere, and Veritas, which will map the surface in unprecedented detail. But here's the interesting part. Both missions were originally scheduled for 2031 and 2032. But in 2023, NASA quietly moved up the timelines. Da Vinci is now launching in 2029. Veritas in 2030. That's not a huge acceleration, but it's significant. Especially when you consider that NASA rarely moves launch dates earlier. Usually they slip later due to budget constraints and technical challenges. Someone wanted these missions to happen faster. And there's more. In 2024, a private company called Rocket Lab announced they're launching their own Venus mission in 2026, a small probe designed specifically to search for organic molecules in the cloud layers. Rocket Lab is a serious company. They don't do publicity stunts. If they're investing in a Venus mission, they think there's something worth finding. But Venus is just one piece of the puzzle. Let's talk about Mars. NASA's Perseverance rover has been on Mars since February 2021, collecting rock samples in Jezero crater. That crater was chosen very deliberately. Billions of years ago, it was a lake. Water flowed in through river channels. Sediments accumulated. If life ever existed on Mars, Jezero crater is one of the best places to look for evidence. Perseverance has now collected 24 sealed sample tubes containing Martian rock and soil. Those samples are sitting on the surface of Mars right now, waiting. The original plan was to retrieve them with a Mars sample return mission launching in the mid-2030s. But in 2023, NASA announced they're accelerating the timeline. The new target? 2028 for launch, with samples returning to Earth by 2033. Again, an acceleration, and a massive one. We're talking about bringing Mars samples back to Earth 5 years earlier than planned. That's expensive. That's complicated. That requires congressional approval and budget increases. You don't do that unless you think those samples might contain something extraordinary. But here's where it gets really interesting. In late 2024, a paper was published analyzing data from the Curiosity rover, which has been exploring a different region of Mars called Gale Crater. Buried in the data, the researchers found something unusual. Organic molecules in concentrations far higher than expected. And not just simple organics, complex molecules, chains and rings, the kinds of structures associated with biological processes. The paper was very careful not to claim biological origin. They acknowledged the molecules could be formed abiotically through geological processes, but the concentrations were weird, the distributions were weird, the preservation was weird, and when you combine that with the fact that Gale Crater also used to be a lake, a pattern starts to emerge. NASA isn't saying it publicly, but privately, some scientists are starting to wonder if we've already found evidence of past Martian life, and we just don't have the tools on Mars to confirm it. That's why they want those samples back on Earth, where we can analyze them with every tool in our arsenal. But Mars and Venus aren't even the most exciting targets. Let's talk about the moons. Europa, a moon of Jupiter. Slightly smaller than Earth's moon, but with one critical difference. Beneath its icy surface lies a global ocean of liquid water, containing more water than all of Earth's oceans combined. We've known about Europa's ocean since the 1990s, but we've never sent a mission specifically designed to look for life there. Until now. NASA's Europa Clipper launched in October 2024. It's currently on its way to Jupiter, where it will arrive in 2030. Europa Clipper isn't a lander, it's an orbiter. It will make dozens of close flybys of Europa, analyzing the Moon's ice shell, mapping its surface, and studying plumes of water vapor that erupt from cracks in the ice. Those plumes are key, because they provide a direct sample of the subsurface ocean without having to drill through miles of ice. If there's life in Europa's ocean, organic molecules from that life might be present in the plumes. Europa Clipper has instruments sensitive enough to detect those molecules. But here's the thing. Europa Clipper was supposed to launch in 2025. It got delayed to 2024 because NASA accelerated the schedule. They wanted it in space faster. And there's more. In 2023, the European Space Agency announced they're launching their own mission to Jupiter's moons, called JUICE, which launched in April 2023 and will arrive at Jupiter in 2031. JUICE will study Europa, but its primary target is another moon, Ganymede, which also has a subsurface ocean. 2 missions, 2 agencies, both targeting ocean worlds around Jupiter. And then there's Enceladus. Enceladus is a tiny moon of Saturn, just 500 kilometers in diameter. But like Europa, it has a subsurface ocean. And unlike Europa, Enceladus is actively spraying water from that ocean into space through geysers at its south pole. When NASA's Cassini spacecraft flew through those plumes in the 2000s, it detected organic molecules, salts, and silica particles. Everything you'd expect from a hydrothermal vent system on Earth. Hydrothermal vents on Earth are teeming with life, entire ecosystems that don't depend on sunlight. Chemosynthetic bacteria that convert chemical energy into biological energy. If the same process is happening on Enceladus, and there's no reason to think it isn't, then Enceladus might be inhabited right now. And we could prove it by flying through the plumes and analyzing them with modern instruments. That's exactly what NASA wants to do. In 2024, NASA selected the Enceladus Orbilander mission as a top priority for the 2030s. But there's growing pressure to move it up. Some scientists are advocating for a faster, simpler mission. A plume sampling flyby that could launch as early as 2028 and reach Saturn by the mid-2030s. If that happens, we could have definitive evidence of life on Enceladus within 15 years. But here's what ties all of this together. NASA isn't just planning these missions in isolation. They're coordinating, sharing data, building towards something. In 2023, NASA established the Network for Ocean Worlds, a collaborative framework bringing together scientists from Europa Clipper, the future Enceladus mission, and exoplanet researchers studying water worlds around other stars. The goal is to develop a unified approach to detecting life in oceans, whether those oceans are in our solar system or light years away. That kind of coordination doesn't happen unless you expect results soon. And then there's the James Webb Space Telescope. Webb has been operational since 2022, and it's revolutionizing exoplanet science. In the past 2 years alone, Webb has studied the atmospheres of dozens of exoplanets. It's detected water vapor, methane, carbon dioxide, and other molecules in alien atmospheres. But Webb is just the beginning. In 2025, NASA announced preliminary designs for the Habitable Worlds Observatory, a space telescope specifically designed to search for biosignatures on Earth-like exoplanets. The Habitable Worlds Observatory will be vastly more powerful than Webb. It will be able to directly image exoplanets, separating their light from their parent stars. And it will have instruments sensitive enough to detect oxygen, ozone, methane, and other gases associated with biological processes. The original timeline for this mission was the 2040s. But, in congressional testimony in early 2025, NASA Administrator Bill Nelson called it the highest priority mission of the next decade. Translation: they want it sooner. Industry insiders are now predicting a launch in the early 2030s, maybe even 2032 or 2033. If that happens, we could be analyzing the atmospheres of potentially habitable exoplanets by the mid-2030s. And if any of those planets have life, we'll know. But here's the most intriguing part. In classified briefings to Congress in 2024, NASA presented findings that have not been made public. We don't know what was in those briefings, but we know the response. Congress approved a 15% budget increase for NASA's astrobiology division, the largest single-year increase in the division's history. That doesn't happen for routine science. That happens when you think you're on the verge of something major. Combine that with the accelerated mission timelines, the coordinated international efforts, and the shift in language from if to when, and a picture starts to emerge. NASA thinks we're close, very close. And if all the pieces fall into place, 2026 could be the year we get the first definitive detection. Here's how it could happen. Scenario 1. Venus. Rocket Lab's private mission launches in late 2026. The probe enters Venus's atmosphere and samples the cloud layers at an altitude of about 50 kilometers, where temperatures and pressures are actually Earth-like. The instruments detect complex organic molecules in concentrations that can't be explained by known chemical processes. Follow-up analysis reveals metabolic signatures, chemical disequilibrium that suggests active biology. Not definitive proof, but compelling enough to demand further investigation. Scenario 2. Mars. Perseverance's samples are analyzed remotely using advanced spectroscopy. The data reveals isotopic ratios consistent with biological fractionation, the kinds of patterns living organisms create when they preferentially use lighter isotopes. Again, not definitive, but strong enough that NASA immediately prioritizes the sample return mission and begins planning for human missions to investigate further. Scenario 3. Europa or Enceladus. This one's less likely for 2026 because the missions haven't arrived yet. But there's a wild card. Juno, a spacecraft currently orbiting Jupiter, has been making distant observations of Europa. If it detects something unexpected in the plumes, something organic, something complex, that could trigger immediate acceleration of follow-up missions. Scenario 4. Exoplanets. James Webb detects a combination of gases in an exoplanet's atmosphere that can't be explained by non-biological processes. Oxygen plus methane. Both gases are reactive and would destroy each other quickly unless something is continuously replenishing them. On Earth, that something is life. Photosynthetic organisms produce oxygen. Methanogenic bacteria produce methane. If Webb finds both on a rocky planet in a habitable zone, that's about as close to proof as you can get without actually going there. Any one of these scenarios could happen in 2026, or 2027, or 2028. The exact year doesn't matter. What matters is that for the first time in history, we have the technology, the missions, and the targets to actually answer the question. Are we alone? And the answer is almost certainly no, because here's what we know. The universe is ancient, 13.8 billion years old. Our solar system is only 4.6 billion years old. That means there were stars and planets for 9 billion years before Earth even existed. Life on Earth arose relatively quickly, within a few 100 million years after the planet cooled enough to have liquid water. If life can arise that quickly from basic chemistry, and chemistry is the same throughout the universe, then it's probably happened countless times. The ingredients are everywhere: water, organic molecules, energy sources. We've found amino acids in meteorites. We've found complex organics in interstellar clouds. We've found water on asteroids, moons, and exoplanets. The building blocks of life are not rare, they're common. So the question isn't whether life exists elsewhere. The question is whether we're technologically advanced enough to detect it. And as of 2026, we might finally be there. But there's another possibility, one that's both exciting and unsettling. What if we've already found it, and we just don't realize it yet? Data from Mars rovers sits in archives, analyzed by algorithms but not fully explored by human eyes. Spectroscopic data from exoplanets contains thousands of absorption lines, most of which haven't been thoroughly examined. Images from Europa and Enceladus show features we don't fully understand. It's possible that the evidence is already there, buried in terabytes of data, waiting for someone to notice. And with the rise of artificial intelligence and machine learning, we're now able to analyze data sets at scales that were impossible even 5 years ago. AI can find patterns humans miss, correlations we'd never think to look for. Several research groups are now using AI to reanalyze old data from past missions, and they're finding things. Anomalies in Martian soil chemistry, unexpected patterns in Enceladus plume compositions, spectral features in exoplanet atmospheres that don't match any known molecule. Most of it will turn out to be nothing. Instrumental artifacts, noise, misinterpretations, but not all of it. And that's why NASA is moving fast, because they know the answer might already be hiding in plain sight. So what happens when we finally confirm it? When we announce to the world that we've found life beyond Earth? Everything changes. Philosophically, it transforms our understanding of our place in the universe. We're no longer unique, no longer alone. We're part of a cosmic community, even if we haven't met our neighbors yet. Scientifically, it opens entirely new fields of research: comparative biology, exobiochemistry, the study of how different forms of life evolve under different conditions. Technologically, it justifies massive investments in space exploration. If life exists on Europa or Enceladus, we'll want to send submarines to explore those oceans. If life exists on exoplanets, we'll want to build starships to visit them. Culturally, it might be the unifying moment humanity needs. A shared discovery that transcends borders, politics, and conflicts. Or it might not change anything at all. Because finding microbial life on Mars or detecting biosignatures on a distant exoplanet isn't the same as meeting an alien civilization. It's important, it's profound, but it doesn't give us anyone to talk to. For that, we'd need to find intelligent life, technological life, a civilization capable of communicating across the stars. And that's a different search entirely. But one step at a time. First, we prove life exists elsewhere. Then we figure out how common it is. Then we search for intelligence. And we're on the verge of that first step. 2026 might not be the exact year. It might be 2027, or 2028, or 2030. But it's coming. The missions are launching. The technology exists. The data is accumulating. And somewhere, in the clouds of Venus, or the ice of Europa, or the atmosphere of a distant exoplanet, the evidence is waiting. We just have to look. And we are looking, right now, with the most advanced tools humanity has ever built. So when someone asks, "Have we found aliens yet?" the answer is, not yet. But ask again in 2026, because by then, we might finally know. Thanks for watching. If you want to follow along as this story develops, make sure to subscribe. I'll be covering every major development in the search for extraterrestrial life as it happens. And don't forget to check out Magic Mind using code ALIENS2026 for 48% off. Link in the description. The universe is vast, ancient, and almost certainly full of life. We're about to find out for sure. See you in the next one.